Hello everyone. Welcome to Tesseract Learning, right? Fine, great. So in last class, what we have done? We were doing this average speed, average distance, this kind of questions we were doing, right? Fine. So after this, we'll go for the next part. So this we have already done, right? What we have done, we have solved few questions and few cases we have seen. Case for equal time interval. So general expression also we have seen. Right. So great. What we can do next? We can solve some questions. This kind of question is already done. So we can do this one. Okay. Let us see this question. Right. Okay. Great. Fine. See what the question says. Question says a particle moving in a straight line covers the first half distance with a speed of 12 meters per second and the other half of the distance in two equal time intervals with speed of 18 meters per second and 30 meters per second. The average speed of particle doing the motion. So this is like the combination. So have we done the case for combination? Let me check. 3 equal time interval. You have not done the case for combination. Yes or no? So let us do one case for combination. So let me just add it here itself before the general expression. Right. Okay, let me check. Do we have space to add or not? Yes, we can do it here, no problem. Right. So that will become case 5. Right, that will become case right. Case 5. Great, not an issue, no issue at all. Okay, case 5 is about combination. Yes or no? So I'll do one thing. I'll try to write from this side. Let me draw a line here. 2/3. We'll keep that in practice. We'll do it in 2/3 part. Okay. So what is case 5? Case 5 is combination. Combination. Right, great. Combination means it is combination of equal time interval and equal distance interval. That's how it is. So suppose the question is like you are going from a point A to a point B and divide the complete distance in two parts. First, you divide the complete distance into equal distance intervals, right? So something like this. First, you divide the complete separation into equal distance intervals such that the first half distance you are traveling with speed v1 and the second half distance, like suppose this is the first half distance x, this is the next half distance x. So first half distance you are traveling with speed v1, second half distance you are traveling with speed, now we are not traveling with speed v2. What we are doing is we are dividing the second half distance in two further equal time intervals, okay, such that the first half time, okay, of the second interval, the first half time you are traveling with speed v2 and the second half time you are traveling with speed v3. Fine. So that's the case. Now we need the average speed for the complete journey. So in that case, what we can do, how to find the average speed? So first what we can do is we can find average speed for this part because this has been divided into two equal time intervals. So first we can find average speed for this part. So what will be the average speed for this part? So for this part, if you see, it is a case of equal time interval. So for this, we can use the formula directly. So for this particular part, let me take a yellow color. Okay. So for this particular part, done, right? Fine. So for this part, the average speed will become, what will it become? We can use v1 plus v2 by 2 formula, but here v1 will be v2 and V2 will be V3. So average speed for the second part becomes V2 plus V3 by 2. Right, so that's the case. Now for the complete journey, now how to find the average for the complete journey? So for complete journey, the average will become, now it's more like first half distance you are traveling with speed V1, and the second half distance, first half distance you are traveling with speed V1, and the second half distance you are traveling with the speed of V2 plus V3 by 2. So that it becomes like a two equal distance interval case. So first half distance you are traveling with V1, and second half distance you are traveling with V2 plus V3 by 2. So for the average speed for the complete journey will become 2V1 V2. So 2V1 into V2 plus V3 by 2 divided by V1 plus V2, right? So V1 is V1 only, but your V2 will be V2 plus V3 by 2. Okay, like that. Fine. Now from here what we can do, you can simplify this. If you simplify this, the 2 in the denominator in both the parts gets cancelled, and upon simplification the average speed will come out equal to 2V1 into V2 plus V3 divided by 2V1, right, divided by, it will become 2V1 plus V2 plus V3. Fine, right? So that's the case here. Okay, great. So this will become the average speed for this case when we have like mixed first half distance. First you are dividing into two equal distance intervals, then you are further dividing into two equal time intervals. In that case the average speed becomes 2V1 into V2 plus V3 whole divided by 2V1 plus V2 plus V3, right? Great. Now let us see this question. So if you see this question is on that format only. So let me again take it to this side. We'll try to write in the 2/3 part only, so that will be better. Right. Now let us see how to do this. So here they are saying a particle moving in a straight line covers the first half distance with 12 meter per second. So here it's the same case, the case of the combination part, right? So first you are dividing the complete journey in two equal distance intervals, right? First you are dividing the complete journey in two equal distance intervals such that first half distance you are traveling with V1, second half distance you are traveling with, the first half distance you are traveling with speed of how much, 12 meter per second, and the other half distance into 18 meter per second and 30 meter per second, right? So first half distance you are traveling with a speed of 12 meter per second, and the second half distance is being further divided into two equal time interval, right, such that the first part of it you are traveling with speed 18 meter per second, and the second part of it you are traveling with a speed of 30 meter per second, right? Clear? Now let us see how to get the answer here. So first we will find average for this part, then average for the complete part. So that's the way to do this one, right? So see, the average for this part will become V1 plus V2 by 2, which is 18 plus 30 by 2, right? So 18 plus 30 becomes 48. 48 by 2 if you do, that will become 24. Fine. Now the average speed for the complete journey, how much will that be? So average speed for the complete journey will be 2V1 V2 by V1 plus V2, right? So 2 into 12 into 24 by 12 plus 24. Now let us simplify this. So this becomes 24 into 24 whole divided by 12 plus 24 will become 36. Now 12 2 times 3 times 8 3s are 8, 8 here. So it becomes 16 meter per second, right? So answer here will become the first option, which is 16 meter per second, right? Right, great. I hope things are clear till here. Right, we'll go for the next one then. Okay, now we'll go for the next concept. So we have seen average speed, average distance, and all these concepts. Now we'll go for the next part. What is the next part? So for next part, we'll first understand graphs. Through graphs, we will try to understand different things, and later we'll connect it with calculus. So first, we'll see the graphs part. Okay, we'll start with the graphs part. So what kind of graph we are going to see here? Okay, let us have a look. Fine. So first kind of graph that we are going to see here. So we'll see what are the different values we get from different types of graph. So first we have position time graph. Okay, first one is position time graph. Fine. What happens in position time graph? Let us try to understand, right? So see, in any graph or from any graph, let me again follow the 2/3 rule only, that will be better. So you have position time graph. So in any graph, three things we find. And if you have any graph, in that graph, three things we will be looking at. One is, the first one is slope, not slope, coordinate. If you have any graph, like for example, let me just draw a rough graph. Let me just check just a moment. What is the format in which it is shooting? Okay, great, no problem. Is it visible? Are things visible? Let me just have a look. Right. So it is able to focus, so not an issue. Right, great. Fine. So position time graph. Now what happens in position time graph? So if you have any position time graph, like in general, if I take any graph like this, right? So here on y-axis you have position x, on x-axis you have time, right? Now what we need to figure out, that what the different points on this graph will give us. Okay, that we have to figure out. So first one is coordinate. What will the coordinate give? Okay, first if I take the coordinate, if I take coordinate of any point on this graph, what will the coordinate give? So if I take coordinate of any point on this graph, that will simply give you position at any instant of time. The coordinate at any instant will give you position at any instant of time. So like the x coordinate will be t and y coordinate will be the x. So this will give you simply the position at any instant of time. So that's that here, nothing too much. Right. So here the coordinate gives position at any instant, right? So in any graph, three things we find: coordinate, position, coordinate, slope, and area, right? Coordinate, slope. I need some water, just a moment. Right. Next one is slope. So what will the slope give? So slope, you can think of slope roughly as division. So if you are dividing, then what do you get? So slope will be simply position by time. Slope, in a way, slope is tan of the angle theta. Suppose this straight line is making an angle theta, right? So slope is tan of the angle theta, and we also know that slope also gives differentiation, or differentiation also gives slope. So in a way, this for this particular graph, the slope will also be equal to dx by dt, and this slope will also be equal to dx by dt. Now what is dx by dt? Dx by dt is nothing but velocity, yes or no? So slope of this particular graph is going to give you velocity. That is what we need to know. So slope becomes velocity. Fine. So in a way, from there we also get this relation that velocity is nothing but rate of change of position. Fine. So if you differentiate velocity position, we'll get velocity as a function of time. Okay, if you differentiate position, we'll get velocity as a function of time. So this point also you can keep in mind, right? Next one is area. What will the area under position time graph give? If I find the area of the graph below position time graph, what is that going to give us? Right. So we know that when we integrate, integration gives us area. So the integration gives us area. So anyhow, so if we integrate, we'll get the area. So that is fine. So that will be integration x dt. Fine. So you can think of integration roughly as multiplication. You can think of integration roughly as multiplication. Position into time. What will be position into time? So what does position into time give? So nothing. There is no physical quantity as position into time. Position by time is velocity, but there is no physical quantity as position into time. So this is, we don't find this. You can say that this is not applicable. We don't find position time like area under position time graph in any question, right? Okay, great. Fine. So what we'll do now, so you understand the coordinate will give you position at any instant, and the slope of position time graph gives velocity. If I talk about area, area does not give any meaningful quantity here. Okay, area under position time graph is not going to give you any meaningful quantity. Fine, right? Now let us see some standard graphs. Okay, so case 1, let us see like how will be the position time graph for different cases. That is what we are talking about here. Okay, so case 1 is object at rest. Fine. If the object is at rest, then how will be the position time graph? And how will be the position time graph of an object which is at rest? Fine. So let us see. So simple thing, if an object is at rest, suppose this is your x and this is your t. So if the object is at rest, then the slope should be 0. And if the object is at rest, then the slope should be 0. Now when will the slope be 0? When will the slope of any line be 0? So slope is 0 when the angle that the graph makes with x-axis, or in this case time axis, should be 0. So it should be a graph which makes 0 angle. So if slope is 0 means tan theta should be 0. So tan theta is 0 means theta should be 0 degree at all the instant. So the object is at rest. The position time graph can be anything. So let me just modify this a little bit. So how can it be? So you could have position time graph like this, or you could have position time graph like this. You could have position time graph like this. Yes sir. Fine. Now in all these three cases, the slope is 0. So body is at rest. Now what is the difference between these three graphs? So the first one, the body is at rest at certain positive x naught, at certain distance from origin, on the right side of the origin. Here in the second graph, the object is at rest at origin itself. In this graph, the object is at rest at origin itself. In this one, what is happening? The object is at rest at certain negative position. At some negative x coordinate, the particle is at rest. So that is the meaning that we have in this part, right? Great. So your graph, if the slope is 0, graph can be any of, if the object is at rest, graph can be any of these three things. If the object is at rest at some positive value of x naught, graph will be like this. If the object is at rest at origin, then the graph will be like this. If the object is at rest at some negative value of position, then the graph will be like this, right? So that's that. Okay, great. Now case 2, let us see. Case 2 is if the object is moving with constant positive velocity. Okay, if the object is moving with constant positive velocity, then what will happen, right? Constant positive velocity, how should be the graph? So we know that the slope of position time graph gives us velocity. So we know very clearly that the slope of position time graph gives velocity. So how the graph will look like? So suppose this is position and this is time. So slope should be a positive constant. So constant positive velocity, so slope should be positive constant. So for positive constant, the slope can be like this, right? It can be this way, or it can be this way, or it can be this way, something like that, or anything like that. Yes or no? Clear? Fine. So here theta should be acute. For constant positive velocity, slope should be positive constant. Okay, for constant positive velocity, the slope should be a positive constant. Now when the slope will be a positive constant, so for constant the graph should be a straight line, and for positive constant, at the angle that the straight line makes with the time axis, that should be acute. Okay, so the angle here should be acute. So theta that we have here, this theta and this theta and this theta, all this should be acute. Okay, so theta should be acute. Fine. Okay, great. So it will be a straight line making acute angle with the time axis. So any of the graph is possible. It can be up, this way, anyhow things are possible. Okay, only thing is that the theta should be acute here, right? Great. Now let us see case 3. Right, case 3. Right, I hope things are visible here. Now case 3 is, so there the object is moving with constant positive velocity. Now let us take a case where the object is moving with constant negative velocity. Fine. So how will that be? How will the graph be if we have constant negative velocity? So for constant negative velocity, what should happen? For constant negative velocity, the slope should be a negative constant. For constant negative velocity, slope should be a negative constant. So negative constant means it should make obtuse angle. Slope should be negative means, if slope is negative means it should make obtuse angle. For obtuse angle, tan theta is negative and should be constant, so it will be a straight line. So graph will be a straight line, and only thing is that it should make a constant obtuse angle with the time axis at any instant. So this is your position and this is time. So how the graph will be? So graph can be like this, or like this, or like this. Any of the possibilities are there. Fine. Only thing is that this angle, so here this angle theta should be less than 90 degree, and this angle theta here should be greater than 90 degree. Fine. Okay, great. So that is that, right? Fine. So slope should be negative constant. Fine. So the angle should be obtuse. Fine. The angle should be obtuse, right? Great. Now, what's the next case? Let us go for the next case here. So let me take the case 4. Case 4 is constant positive acceleration. Fine. So the body is moving on a straight line with constant positive acceleration. So in that case, how will the position time graph be, right? So again, this is a part where students do feel difficulty. So pay attention. It's a very simple graph. Nothing too complicated here. It's a simple graph only, right? So constant negative acceleration means the acceleration should be constant and negative. Now what is that supposed to mean? Not negative, positive, right? So if acceleration is positive, constant, right, then the speed will be increasing. The speed will be increasing, so slope should be increasing at a constant rate. So it will be a graph with an increasing slope. So if the acceleration is constant, the slope should increase, and at the same time the slope should increase at constant rate, because if the acceleration is constant, the velocity will be increasing at a constant rate. So here the slope should increase at constant rate. So for slope to increase at constant rate, the graph comes out to be upward parabola. Okay, so if the slope is increasing at constant rate, then the graph will be an upward parabola. Fine, that is how the graph will be. It will be an upward